All right, Math 2, here we go. We've got 9-5. We're going to factor x squared plus bx plus c. So basically, we're going to take a trinomial that doesn't have a number in front of the x squared and learn how to factor. Remember, when we factor, we're turning these problems into multiplication problems. So factoring is kind of like the opposite of multiplying. So what are the rules for dealing with negatives when factoring trinomials? So what do we do when we have negatives in our equations? What are some of the things that we can do to remember what happens with those negatives? Anyways, here we go. So when we do multiplication, and we did multiplication, we kind of did it with the area model. If I took x plus 8 times x plus 5 and put it into my little area model here, we do x times x, and that'd be x squared. We do 8 times x and get 8x. And then we do 5 times x and get 5x. And then we get 5 times 8 and get 40. So we've got like terms here in the little peanut. So we would have ended up getting x squared plus 13x plus 40. So that's what we have here. We're going to now factor this. But knowing where these numbers comes from is going to help us to factor it. For instance, where does the 13 come from? Well, from these starting numbers, that's 8 plus 5. That's where the 13 is coming from, because here they were like terms right there. Where did the 40 come from? That came from 8 times 5, because that's this box over here where we're multiplying the 8 times 5. So when we get to this problem, what we're really looking for is two numbers that multiply to give us 40, but add to give us 30. Because remember, we were multiplying them and getting 40, and we're adding and getting 13, not 30, 13. So in order to factor these problems, what I suggest that you do, which I want you to do, is I want you to set up a t-table with that last term in it, 40. Now let's think of all the different ways that we can multiply and get 40. Let's start with 1. 1 and 40. What about 2? Yep, 2 goes in there. 2 and 20. These are all the ways to multiply to get this number. Okay, does 3 go there? No. 4, yep. 4 and 10. Does 5 go in there? Nope. 6, nope. 7, nope. 8, yeah. Oh, 5 did. 5 and 8. Missed that one. All right, so what we would ask ourselves is, okay, so I've got a number that's multiplying to give me 40. Of its multiples over here, which one's going to give me 13? Well, 8 and 5 are going to give me 13. So I would write my answer as x plus 5 and x plus 8. We know that we have to start with x and x because that's how we're getting the x squared over here. And then 5 times 8, that's where we're getting the 40. 5 plus 8, that's where we're getting the 13. We can kind of see that when we multiplied it out. All right, so let's go ahead and practice that. First of all, I am going to start by doing a little t-chart over here. So I'm going to take my last number of 75, and I'm going to think of all the different ways that I can multiply and get 75. So I always start with 1. So 1 and 75. 2, no. 3, yeah, because 3 times 25. 4, no. 5, yeah. How many times does 5 go in there? 5 goes in there 15 times? 6, no. 7, no. 8, no. 9, no. Okay, that looks like all of them. So we ask ourselves, do any of these add up to 20? And yes, 5 and 15 add up to 20. So we set up our two parentheses. We start our parentheses with x because x times x is where we're getting this x squared from. We end our parentheses with positive 5 and positive 15. Because 5 times 15 is 75. And then this is 5x and this is 15x. So 5x plus 15x is the 20x. So adding these two gives me this. Multiplying these two gives me that one. All right, example 2. We're going to take our last term, which is 6, and find out what multiplies 6. 1 and 6, 2 and 3. Now, do any of these combinations add up to 7? Yes, 1 and 6 does. So we're going to start our parentheses with x, because x times x is x squared. And then we're going to do x plus 1 and x plus 6. Because when you multiply it, you get 6. When you add it, you get 7. So 1 times x and 6 times x, that's 1x and 6x. That's where we're getting the 7x from. So we're just undoing the multiplication and making it into a multiplication problem. Now, if you multiply this out, you should get what you started with. All right, what if there were a negative number in the middle here? So this is our b value. What if the b value was negative and our c value is positive? Well, remember where these numbers are coming from. I have to multiply and get positive 36, but I have to add and get negative 15. The only way that you can multiply and get a positive number, but add and get a negative, is if both the numbers are negative, because a negative times a negative would be positive. So I'm going to write down all of my different numbers that could work. So negative 1 and negative 36, because I decided both my numbers have to be negative because I'm adding up to a negative in the middle, but multiplying here and getting a positive. So negative 1 times negative 36, that would be negative 37. That's not negative 15, not quite there. So now we're going to go negative 2 and negative 18. That's negative 20, not negative 15. We'll do negative 3 and negative 12. That's negative 15. Usually I would want you to keep on going and get all of your factors down. So negative 4 and negative 9, and then negative 6 and negative 6. These are all the possible combinations to multiply and get positive 36. But we decided all of these have to be negative because when you multiply them, you get a positive. When you add them, you get a negative. So my two that give me negative 3 and negative 12, those are the two that add up to negative 15. So we start off our parentheses with x, because x times x is x squared up there. And then we end our parentheses with negative 3 and negative 12. So they're multiplying and giving me positive 36. They're adding and giving me negative 15. All right, next one, we're going to take positive 16. So it's multiplying to give me a positive, but it's adding to give me a negative. That means both of these numbers are negative. So negative 1 and negative 16. Negative 2 and negative 8. 3 doesn't go in there, 4. Negative 4 and negative 4. Those are all the combinations that multiply to give me 16. Now, do any of them add up to negative 10? Yes, negative 2 and negative 8. So I'm ready to write my two binomials down. I'm going to start with x on both of them because it's going to be x times x equals x squared. And then I'm going to end them with negative 2 and negative 8. So x minus 2 and x minus 8. They multiply and give me positive 16. They add and give me negative 10. All right, what if the c is negative? Well, if the c is negative, that means if I'm multiplying, one of my numbers has to be positive and the other one has to be negative. So I'm multiplying, one's positive, one's negative. Now over here, this is positive, which means the bigger number has to be positive, because if one's positive, one's negative, I'm going to subtract to get 11. So that means one of the numbers is positive, one of them's negative. So I'm going to do negative 42. Now my smaller number has to be negative, and my bigger number has to be positive, because they're multiplying and give me negative 42, but these two are adding together and giving me positive 41. Now that's not the 11 that I want, but it's got the right sign. It's a positive sign, right? Because negative 1 plus 42 is positive 41. Okay, keep on moving. We're going to do -2 and -21. Oh, +21, dang it. So here I get +19. We're closer to 11, but not quite there. 3, yep, 3 works. -3 and +14. Any other numbers? 4, no. 5, no. 6, yes. -6 and 7. All right, those are all my combinations. Do any of those add up to +11? Yes. -3 and +14 do. So in my parentheses, I've got x, and I'm going to multiply it by x. And I've got x -3 right here, and x plus 14 right here. Because when you multiply them, you get -42. When you add them, you get +11. Now this one has a negative in the middle and a negative at the end. So if there's a negative at the end, one of your numbers is positive and one's negative, because you multiply and get a negative, one of them had to have been negative. But since this number here is negative, that means my biggest number is negative and my smallest number is positive. So I'm going to have -18 over here. So I'm saying that my bigger number is negative. So this would be 1 and -18, 2 and -9, 3 and -6. Okay, so of those combinations, are any of them giving me -17? Yes, the first one. 1 minus 18 is -17. So see why we made the bigger number negative? Because we had a negative right here. So the bigger number had to be negative. So we're going to lead off with x. And then +1 for this one, and -18 for this one. When you multiply them, you get -18. When you add them together, you get -17. All right, let's look at a couple more things. Example 7. Ooh, I added in some b's there. Is this going to change how we do the problem? Not much. So over here, I've got a -48. So I'm going to just start off with -48. That means one's positive, one's negative. Now, is the bigger one positive or negative? Well, this is negative, so my bigger number is negative. So I put my big ones on this side. So this would be 1 and -48. 2 and -24. 3 and -16. 4 and -12. 5, nope. 6, yep. 6 and -8. And those are all my combinations. So do any of those combinations give me -8 when I add them together? And yes, right here, 4 and -12. Those two together are going to give me -8. All right, so I've ignored the B up till now. Now I know that my starting letter has to be A, because A times A is A squared. Now this ending number has to be B squared. So I need a B at the end here and a B at the end here, because B times B would be B squared. And then one of the numbers is going to be plus 4B. The other number is going to be minus 12B. And here we can see that we're getting this AB in the middle because these two are multiplying and giving me 4AB. And then these two are multiplying and give me -12AB. And that's where this -8AB is coming from. So if you see a B squared at the end, just put B and B. A squared at the beginning, A and A. There you go. All right, next one. We've got -120 at the end. I've completely ignored the x to the fourth for right now. It's not scaring me at all. So I've got -120 over here. That's a lot of combinations. This one's positive, so that means my positive number has to be bigger. So the smaller number is negative, my positive number is bigger. So -1 and 120. 2 goes in there, so it'd be -2 and 60. 3 goes in there, so -3 and 40. Okay. 4 goes in there. Wow, there's going to be a lot of these. 4 and 30. 5, dang it, 5 goes in there too. 5 goes in there, what's that, 24 times? 6, yep. That's the worst number ever. 6 goes in there 20 times. See how the numbers are getting closer and closer together? That's when I kind of know to stop, when my numbers are right next to each other. 7 doesn't go in there, finally. 8, dang it, 8 does go in there. Negative 8 and 15. Does 9 go in there? No, 9 doesn't. Does 10? 10 goes in there. Almost forgot about 10. Negative 10 and 12. Okay, I think I finally got all of them. So I need the one that comes out to 2. Oh, this is the last one I wrote down. There you go. There's our value that ends up 2. Now, when I start my parentheses, this is x to the 4th. So that means this is x squared and x squared, because x squared times x squared is x to the 4th. And then we'll do minus 10, and then we'll do plus 12. Because when you multiply negative 10 and positive 12, you get negative 120. And then these two give you negative 10x squared, and these two give you 12x squared, which gives you 2x squared in the middle. All right, next one. 2 is our number at the end. This one's negative. That means both of these numbers are negative. So negative 1 and negative 2. That's the only combination. Okay, since this is positive and this is negative, both of these numbers have to be negative. But this gives me negative 3, not negative 1. Problems. So at this point, we can just say that this is prime, because there are no combinations of 2 that give me negative 1. So this is a prime problem. The only combination that gave positive 2 was negative 1 and negative 2. Now you might be thinking, well, why didn't you use positive 1 and negative 2? Because that gives you negative 1. But when you multiply them, you get negative 2, not positive 2. So there are no combinations that work for that one. If no combinations work, you can just write the word prime. Last one, 72. So this is negative 72. One's positive, one's negative. This number is negative. That means my bigger number is negative. So I'm going to use 1 and negative 72. Doesn't work. 2 and negative 36. Nope. 3 and what's that, 24? Still doesn't work. Next one, does 4 go in there? Dang it, yes it does. 4 and what's that, negative 18? No. 4 and, yeah, I think it's 18. Negative 18, yeah, that works. 5 doesn't work. 6, okay, 6. And how many times? 12. 7, no. 8, yes. 8 and negative 9. All right, there's all my combinations. The only one to come out to negative 1 is 8 and negative 9. So I start my parentheses with an x and with an x. And then since I have a y squared at the end, I have to end with a y and a y. And then we're going to do x plus 8y, and over here x minus 9y. When you multiply 8y and negative 9y, you get negative 72y. When you multiply 8y times x, that's 8xy. When you multiply x times negative 9y, you get negative 9xy. So here's your negative 1xy when you combine these. That's why we're getting negative xy right there. The end. Do not forget to write down your summary, which is, what are the rules that we talked about when we have negatives and we're factoring these trinomials? Okay, there were negatives here in this problem. So this last number was negative. Remember we said, well, if this last number is negative, one has to be positive, one has to be negative. And if this middle number is also negative, then the biggest number has to be a negative number. So those are the types of rules that we talked about. All right, people, that's all I got for you. 9-5 factoring. We will do the factoring with a leading coefficient next time. It'll be delicious. I'll see you then. Bye-bye.